Welcome to another feed scroll generator tutorial for Autodesk Inventor. This is a fun one this time. We're looking at how you can create splitter shafts like the ones that we see in front of us here, where the bottles are alternately going left and right and end up with two separate paths of bottles by the end of the shaft. Now it looks complex, but in version 5 of the app and onwards we've got some fantastic tools to actually make it pretty straightforward to create shafts like this. First thing to note is that obviously each shaft is doing two jobs here. It's kind of pulling one set of bottles towards itself and it's pushing the alternate bottles away from itself, and both shafts are doing that. So as we saw in the last tutorial, number 10, we are creating two threads on each shaft here, not a single thread. We have to first cut the first thread and then retain the first thread and cut the second thread. Let's just spin this model around a bit. If we take a look at it here, you can see that these shafts are actually moving towards each other. They're rotating towards each other. That's something you'll want to bear in mind when you're creating the layout or the design for a splitter shaft like this. Do you want the shafts rotating towards each other or away from each other, or do you want them to be rotating in the same direction? Because obviously that will affect the sequence in which you create the shafts. Let's hit the delete key on the keyboard to stop this simulation and return to the parent part from which we started. And if you want to brace yourself for some blinding white light, we're going to switch over to PowerPoint to take a look at the top level steps that you can follow for pretty much creating any double splitter shaft and then simulating it using the app. Okay, so here's the top level steps. You can see there's 9 steps really to creating a double splitter shaft. Looks complicated, it really isn't. I won't go through every single one of these now because we're going to be referring back to this throughout this tutorial to make sure that we're on track with the steps we should be following. What we'll do is we'll just jump in and start out with step 1 here, which is take the time to create yourself a layout sketch showing the paths that you want the bottles to follow, because of course, as we saw a moment ago, the bottles are going to be following both an inner route. So if you take a look at this sketch here, this is the shape of the shaft, and then you've got the bottles taking an inner route towards the center of the shaft, and then you've got the alternate bottles taking an outer route away from the center of the shaft. Now there's a couple of constraints on what you can and can't do with these two paths, as you'd expect. How far can you go in and out away from the shaft? Well, I think we're going to jump now into an Inventor part that I've created for this very purpose, and we'll make some tweaks to it and I'll show you the parameters we can use. Okay, so I've sketched out the shaft shape here with the center axis of the shaft, and I've sketched out the inner and outer routes of the bottles here as well. So here's the inner route of the bottles and here's the outer route of the bottles. I've sketched them away from each other at the moment just to make it clear what's going on, but I want to go into this sketch and move these items around to see what the limits are of the different positions for these that I can use. So let's go and edit this sketch. Okay, so inside the sketch now, we're going to basically be moving the bottle routes over the top of the shaft, and we're going to end up with something like this. But what are the limits with that? Well, there's a pretty simple initial limit to the routes these bottles can take here. We can't have the inner bottle, which is the one I'm dragging at the moment, going over this center shaft axis. So this is okay, but this here is not. If I just zoom in a bit, we'll see a bit more clearly. See, so here is okay because it's this side of the center axis. If I move it over, this is not okay. The app won't currently support that, but we can put it as close to the center axis as we want. So let's stick a dimension on there to start off with, because this is one of the benefits of Inventor sketches. You can parametrically constrain things as you go. So I'm going to stick a dimension on here between there and there, and I'm just going to make that, let's say, 0.5 millimeters. That can be as close as I like there. And now what I should be able to do is to drag this one around, this bottle route around, and this is where, as I said, the stretchy nature of Inventor sketches, if you constrain them correctly, is useful. As you saw in the note just now, this part is available for download on our website. You can click on the link below the video here, and you can use this to help you specify your own splitter shafts as well. So we definitely want the bottles to be separated from each other, but how far can we go out away from the original bottle? Well, it depends on how much material we've got for the shaft here. So we've got 135mm diameter shaft here at the moment, but you know, we can make that whatever we like depending on our physical limitations, but we need this bottle to be on top of the shaft a little bit, otherwise this shaft isn't going to be able to do any of the job of pushing the bottle away from this other bottle here. So let's see if we can stick a dimension on that. Let's just say we want at least 10mm overlap. Maybe we could make that a bit less, can we, to split the bottles a bit more, maybe 8mm, something like that. So if I stick another dimension on here, we've got 9mm. I'll accept that that's a driven dimension. We've got 9mm of separation between these two bottle paths here. Okay, and then, you know, in this sketch is also useful for me to try out some other things. I can see what it will look like as a shorter shaft, 500mm shaft versus 600mm shaft. I can see what happens if I change the length of these lead in and lead out values and so on and so forth, but I'll just leave these as they are with this initial design that I've set up here. Also interesting to see what happens if I make the bottle size bigger and smaller. You can see with a bigger bottle there, obviously it's more difficult to separate it. It's easier with a smaller bottle, but I'll leave this as the values that I've set up here, and we'll come back to this sketch and refer to it as we're actually creating our part now in a moment. So hopefully you see how useful it is to create a sort of layout like this, so you can get your bearings before you start typing these numbers into the app to be sure that the design you're specifying actually makes sense. Okay, so I'm going to finish this sketch, and I probably want to turn on the sketch dimensions so that I can see it without editing the sketch every time. So I'll right click dimension visibility, and there I've got all the numbers that I want to make use of when I head back into the app. So I'll save this part, and let's create ourselves a new empty part file so that we can start building the first shaft. So I'll hit generate, and let's get the general dimensions set up how we want it. So length of the shaft is 600, diameter of the shaft was 135, wasn't it? The bottle diameter was 50mm, so let's click the edit bottle sketch here. It's already 50, so that's convenient. Let's finish that sketch. So the bottle pitch is going to have to be at least 100 at the start. That would give us 0 clearance between the bottles. So maybe if I make it 101 at the start, because of course we're cutting 2 threads. As you saw in the last tutorial, we need to cut the alternate thread here between this thread. Okay, so we need a double pitch here effectively, and then at the end we don't have to change the pitch at all, because I guess the main function of this shaft is to split the bottles, but we may want to change the pitch as well. Just for the sake of this example, maybe let's make the pitch at the end 130mm, so we are slightly separating these bottles. And then, as we usually do, the start lead in amount is how far at the start before the bottles start changing pitch, so we'll make that 1 revolution, and how far at the end after they stop changing pitch, we'll make that 1 revolution as well, so make these numbers the same. Okay, so now we come to the interesting bit of how far do we want to position our bottles from the shaft axis, the position in this direction now. So we definitely do want a variable distance from axis turned on, and in order to determine the start and the end values here, we're going to have to refer back to our layout sketch, which is why it's so useful. So let's head back to the layout sketch here. So the position at the start of the bottles is 109 on the diameter to the center of the bottle. So let's head back to our part here. So that's going to be 109. Okay, and then the position at the end, if we now refer back to our PowerPoint, we're starting to cut the inner thread first. Doesn't matter if you do this the opposite way round, but all these instructions here, I've assumed you're cutting the inner thread first, because we have to do the opposite thing around this time for the second shaft. So let's cut the inner thread. Let's take a look on our layout sketch what the inner thread position of the bottles is going to be. So on the diameter, that's going to be 49 millimeters to the center of the bottles. Let's switch back to the part we're building, and let's make this 49 at the end. And then, so you can see the bottles very close to the shaft axis but not touching, which is perfect. And then how far do we want to go before we start moving the bottles inwards, and how far at the end? We put that on our layout sketch as well, didn't we? So I think we used the values of 150 at the start and 150 at the end. So that's easy enough for me to plug in here. Okay, there we go. So for this example, to avoid doing too many things at once, we haven't got any bottle rotation. As you saw in the last example, tutorial number 10, we can easily include bottle rotation in a double shaft, and that example shows it. But let's put the bottle oversize in. I do like using this new feature in V5 to allow some automatic clearance to the bottles. So we'll start out with, let's say, 8 millimeters at the start. Let's maybe end with 1 mil clearance at the end of the shaft, and I want the clearance to change to the finished value pretty quickly. So I'll say the end lead out is maybe going to be 500, or maybe that's a bit too much. Let's make it 450. So you can see the oversize quickly decreases down to the end value of 1 millimeters. That's 1 millimeter on the diameter, so this is 0.5 of a millimeter clearance we're providing here. Okay, and let's have a look at the other settings we need to use. So we definitely do want a single face. No need to create multiple helical faces for a simple example like this, with a simple circular bottle shape with no rotation of the bottles. We're not going to need a lot of loft profiles. We'll leave this kind of low here. Loft rails, not going to need a lot. Again, simple bottle shape. And we're all good to go. Let's just make a note of what the shaft rotation is. So we're starting out with right hand shaft rotation here. So probably before we go any further, I'm going to save this part, save it in the right folder. So I'm going to call this, let's save it in the right folder here, right hand splitter, I'll call this. Okay, and with that saved, we can go and hit generate, and that will then be the first thread, the inner thread cut for this first right hand part. I'll speed the video up. Okay, this shaft's created in just under 2.5 minutes. So I'll say yes, I do want to continue with another operation, because of course I want to now cut the outer path. And this is really easy. We can just say that we want to cut the second thread here and decide how much we're moving the first thread around so that the two threads aren't cut on top of each other. So we're just going to rotate the shaft 180 degrees to cut the second thread. So if I click off of there, you see the preview, which is great. The two threads aren't going to be cut on top of each other, but of course we also need to change the position of the bottle because we're cutting the outer root here for this path. So let's head back to our layout sketch. We've cut the inner root, we're now cutting the outer root, which has a position of the bottles of 169 millimeters on the diameter for the center of the bottle there. So let's head back here, and we want to specify that here. So that is, instead of 49 millimeters, 169. Hit enter. Okay, and we can see that we do have some shafting contact with the bottles here, so that it will be pushing the bottles out towards the outer path here, and we're pretty much ready to hit generate and create this second root here. Okay, we've got the second thread cut in 2 minutes 20 seconds or so, and I'll say yes again, I do want to continue with another operation. because actually what I want to do, if I just save this part, is I want to follow the instructions on our PowerPoint, which is to simulate the bottle movement just to confirm that everything's working correctly with the inner and the outer path for the bottles. So let's head down here and let's just hit simulate. Okay, you can see the soft entry here for the bottles. We provided that clearance, didn't we? Going down to a clearance of 1 mil or 0.5 mil on the radius. So that's looking good. And then if I just drag this slider along, you can see that this is doing exactly what we asked it to at this point. So now, if we escape out of this simulation, we are pretty much just going to copy this part and reverse a few things and hit generate again a couple of times, and that's it. We've got both halves of this splitter shaft created. So let's save this and let's close the form down there, and let's save as this file. So let's do a save as, and this one was called right hand splitter, wasn't it? So let's name the next one, not too inventively, left hand splitter, and let's save that. And then let's hit generate again in here, inside this new part here. And then you can guess by the name what we're going to be doing here. We're going to be switching the shaft rotation to left-handed. Let's just check our PowerPoint for the instructions of what we should be doing next. So we did the save as to create the second shaft file. We don't have bottle rotation, so we can ignore step 6. If we did, we would have to switch the bottle rotation from anti-clockwise to clockwise or vice versa. And now we're down into step 7, 8, 9, and we've got two options. Do we want the shafts rotating in opposite directions, or do we want the shafts rotating in the same direction? Well, we'll go for opposite directions here. I think that's possibly more common. So we'll change the shaft rotation for the second shaft, which we've done already. And then we need to create the outer thread on the second shaft. Now, this is important. You see here, we've got instructions to create the outer thread before the inner thread. Whereas for the first shaft, we created the inner thread first and then the outer. We have to do it the other way round this time. That's because this is the opposite shaft. So let's head back to Inventor. And we're already creating the outer thread here because that was the last one that we created on the first shaft. So it is literally just a case now, having changed the shaft rotation to left-handed, we can leave it on the default, which is cut the first thread. This is going to delete the existing solid body, which is again exactly what we want here. So I'm going to hit generate, and it's going to give me that warning because it's going to delete some existing work we've done. And so I'll say, yeah, continue with that, and I'll speed the video up here. Okay, that's the outer thread created. I'll say yes, I do want to continue with another operation again, and we're going to repeat the steps here except with the inner thread. So we'll cut the second thread as the inner thread. So yes, we do want to cut a second thread. Let's rotate the shaft by 180 again. And then we need the end distance of the bottles from the shaft to be that defined by our layout sketch, which is 49 millimeters, isn't it? Yep, so let's head back here and let's change that to 49. And we can hit generate again. Okay, we've got the finished shaft again, 2.5 minutes, and we'll say yes again, we do want to continue with another operation because we're actually ready now to start simulating both of these completed shafts. So we'll just save this shaft first, and then if we run a simulation of this one down here, then we'll have the option to add the right hand splitter part to the same simulation. Okay, so here's this one. Let's just double check that this is doing what we expect, which it is. You can see the soft entry clearance that we added, that we kept the same here for this part. And here's where we can just add the second shaft to the simulation here. So it's this button here, as you saw in the last tutorial, and we need to add the right hand one, isn't it? So yeah, so if I pick the right hand splitter shaft here, that's going to add it into the simulation. and if I drag the slide around, you can see that both of those shafts are controlling the bottles exactly as we asked them to. Now if we just refer back to our PowerPoint for a moment, we've got here steps to simulate the double splitter shafts. So we've simulated, we've added the second shaft, and we've got the options here depending on whether we chose option A here or option B here. We've got the ability here to make the simulation match that setting, whether we've got opposed or identical bottle rotation. So in this case we did choose opposed bottle rotation, didn't we, because we have one right-handed shaft and one left-handed shaft. But if we had the opposite, we would just right click and choose identical here, and then we would get the correct movement of the bottles. But this looks perfect to me here. We've got a really nice clearance around the bottle as we defined, and this looks good to go. Thanks very much for watching and have an excellent day.